Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel, Pharma World. Today's topic is basic statistical tools and charts. There are several statistical tools to establish a monitoring system to see that the manufacturing process is always under control. After them, few tools and graphs which are important for manufacturing are discussed in this video. This video also explains how to use the Excel spreadsheet for calculation purposes. The only way to ensure quality of the product is to build quality into the process. Quality is built in the process. Monitoring or testing is only a confirmation whether or not the process yields correct output. There are several specific statistical tools to help monitor the process at all stages of manufacture. By just tabulating the data on an Excel spreadsheet does not mean that the data is evaluated. Scientifically, evaluation is done by statistical tools. These are measurable and specific. So it has to be applied all across all processes at all stages. These tools identify quality problems and help to fix appropriately. The outcome of the statistical data identifies the problems in the manufacturing and will help to design the process with corrective and preventive actions at any stage of the manufacturing process. Descriptive statistics such as mean, range, data distribution, standard deviation, etc. are very useful for identifying the quality problems. These tools will help to monitor the data for compliance. These tools also provide significant insight into the central tendency and variability of the process, whether or not the process is centered and how much is variability can be obtained from these tools. Let us understand each of these functions: mean, standard deviation, range, etc. Mean or average. Mean is a parameter which describes the central tendency of the set data. It is a simple calculation. It shows what is the central value of the process data. Mean is calculated by summing up all the individual data numbers and divide with the number of data points. The formula is x bar is equal to summation of individual numbers divided by the total number of data points. You don't have to worry too much about manual calculations. Your Excel sheet will do it for you. If the data is only 5 or 6 points, manual calculation may be possible. But if the data is too much, it is recommended to take the help of statistical tool function key on the Excel spreadsheet. We will learn more in the coming up slides about this. Xi is the individual value, n is the total number of data points in the set, x bar represents mean, and the symbol for summation is this. Look at this simple example. Tabulate the data in the Excel spreadsheet from cell A1 to A10. In this, you can clearly see A1 represents column A and row number 1. Same logic applies for all other numbers from A2 to A10. Now select the cell address where you want the average value to appear. In this case, it is A11. Then go to the formula bar and start with an equal to sign. Then type average and start the opening bracket. Select the data for which the average has to be determined. In this example, it is A1 to A10. So you have to write as A1 colon A10 and close the bracket. Now press enter. You get the result in the designated cell A11. You can clearly see that the data selected is between A1 and A10. It is very simple. This is the icon for selecting the statistical formula in the Excel spreadsheet. You browse the drop-down list. You get a lot of formulas with brief explanation on its function. Let us see what is a range. The difference between the largest and the smallest observations in a set of data. By simple logic, the value between the maximum and minimum is called a range. Larger the difference, higher the variability, and smaller the difference, lower the variability. Obviously, more the difference between the largest value and the lowest value, the range or variability is more. Range R is calculated by subtracting the smallest observation S from the largest observation L. The formula is R is equal to L minus S. Look at this example. Same logic as in a mean applies here. Select the cell address where the result should appear. Here in this case it is A11. Go to the formula bar and type equal to sign and max and enter A1 colon A10 minus minimum and enter A1 to A10. The formula is self-explanatory. In the selected cells, it identifies what is the maximum number and subtracts the minimum number from the data set. It is 1.6. You can check manually also. The maximum value is 100.3 and the minimum value is 98.7. The difference is 1.6. As told earlier, if there are smaller number of data points, it may be easy to do manually. But if the data is too much, this is the way to do. But it is necessary to know the basic concept with which these formulas work. Standard deviation is another measure for variation. It is calculated by this formula. Let us see what is standard deviation. As told, it is another measure of variation. Here also, your Excel spreadsheet will help to do this for you. But for fun, you can try once or twice. The standard deviation is represented by the symbol sigma. The calculation is done as follows. Average value of the entire set is subtracted from each individual value and square of the difference is computed. Then all the computed square values are added up. This is represented by sigma xi minus x bar. This is the numerator of the formula. This is divided by n minus 1. This entire value is square rooted. Then you get the standard deviation. In this formula, xi is the individual value of the data set, x bar is the average of the data set, and n is the number of data set in the entire example. See this example? List out the data in column A from A1 to A10. A11 is selected for standard deviation value. The formula is equal to sign, then type stdev, then insert the data cells as A1 colon HN, close the bracket and enter. You get the value in the designated cell A11. The value is 0.548229. Let us calculate manually. 99.45 is the average value of the data. These values are xi minus x bar. These values are squares of each difference. The number 2.705 is the sum of all squares. This is represented as sigma xi minus x bar square in the formula. This 2.705 will be divided by 9, which is n minus 1, will give you this value of 0.300556. Square root of this value is 0.548229, which is same as computed by the Excel sheet. It is simple. You have to understand this computation of simple formula. Normal distribution with varying standard deviations. This is interesting. You can see the significance of standard deviation in this example. For lowest standard deviation of 80, the spread is between 800 and 1200 approximately. This is closer to the median. For standard deviation of 120, the spread is between 600 and 1400, which is wider than the earlier one. See the third distribution curve at standard deviation of 190, the spread is still wider at 400 to 1600. So the point here to understand is that lower the standard deviation, better the control on process. Let us understand what is a X bar graph. This is a mean average control chart which provides the central tendency of the process. Remember, whenever there is a reference to the word bar on any letter, the data considered for evaluation is mean or average values. X bar graph is very useful graph to establish the central tendency of the process. In this, mean of smaller subsets of samples is considered for plotting into a control chart. First step is to take average X bar of set of individual multiple samples, say approximately 4, and continue for a good number of samples, preferably more than 10. So data from a subset of 4 or 5 samples will be tabulated and its average will be computed. This is called X bar. For control limits, X double bar will be taken into consideration. This is done by summing up of all averages divided by the total number of averages. Double bar indicates average of averages. Calculate the upper control limit and lower control limit by the formula UCL is equal to X double bar Z into standard deviation by root n, and LCL is X double bar minus Z into standard deviation by root n, where n is the number of subset points. The upper control limits and lower control limits are calculated as per these formulas. In this, Z is the statistical number considered for a normal distribution of 3 sigma, in which 99.73% of the data points are within this confidence. You can have 2 for 99.45% confidence. The value is 68.27% confidence for 1 sigma. Here n is the number of subsets considered for X bar graph. You can see example Excel spreadsheet after next 2 slides. Remember these figures for plus or minus 1 sigma, plus or minus 2 sigma, and plus or minus 3 sigma from the mean. Mostly we will be using 3 sigma values only for X bar graphs. In the formula, Z is the standard normal variable, which is 3 for 99.73% confidence. STD by root n is standard deviation of the distribution of the sample means. In the example in next slide, the calculation is as follows. The upper control limit is calculated by the X bar value, that is 99.59, plus 3 into the standard deviation of 0.5 of the process divided by the square root of the number of subset points, which is 4. The value is 99.59 plus 3 into 0.5 by 2, which is further calculated as 99.59 plus 3 into 0.25, which becomes 99.59 plus 0.75, which yields 100.34 for the upper control limit. Similarly, you can calculate the lower control limit and the value will be 98.84. See this example X bar plot. Value 1, value 2, value 3 and value 4 are taken and each average is computed as X bar. Similarly, for each set of 4 data points, the average is computed. Range is the difference between the largest value and the lowest value. We will learn about range graph in next few slides. You can see the computed upper control limit, lower control limit and the standard deviation. Here is the X double bar value 99.59. This is the central line at 99.59 and the upper control limit and the lower control limit are on either side of the central line. These calculations are done by the Excel sheet itself. This is the central line. The formula for X double bar is this. The range graph provides information on variability of the process. Range graph establishes variability in the process. For range graph, we have to calculate R bar. This will be the central line for the range graph. For range graph, first you have to calculate R bar. This is calculated as average of ranges in each subset of data. Initially, for range values, go to the formula bar, type equal to symbol and then type maximum and give the range of data cells within the bracket minus minimum and give the same range of data cells within the bracket. In this example, you have to type A2 colon D2 for range of data cells. Continue for A3 colon D3, A4 colon D4, etc. till A20 colon D20. You get individual ranges. For R bar, go to the formula bar again and type equal to symbol and type average and give all the range cells within the brackets. In this example, it is F2 colon F20. You get the value of 1.04. You can see in the previous Excel spreadsheet example for R bar as 1.04 in cell address H2. For calculating UCL and LCL, the formula is given as below. UCL is equal to D4 into R bar. LCL is D3 into R bar. Factors for 3 sigma controls for R charts are D3 is equal to 0 and D4 is equal to 2.28 for a sample size of 4 observations. UCL and LCL are calculated as given below. Factors of D3 and D4 are statistically derived figures. We are taking these factors as such and are not discussed in this video in detail how these figures are derived. See this R chart example. Central line is 1.04. This is obtained from
the previous example. D3 is 0, D4 is 2.24, UCL is D4 into R bar, which is 1.04 into 2.28, which is equal to 2.3712. This is the formula bar for that. Since D3 is 0, the LCL will be obviously 0. If the graph lies in between LCL and UCL, it can be established that there is no significant variability in the process. And this is the central line of the R graph. Let us see the importance of X bar and R charts. The X bar charts provide information on the central tendency of the process. The data is mapped against the average of a set of data points. Average will tell information on central tendency of the process. Hence, this chart will be very useful for establishing the central tendency. The R charts provide information on the variability of the process. Range talks about the difference between the smallest value and the largest value. This obviously gives information on variability. I hope that these simple tools are useful for your routine evaluation of data. Make nice, colorful graphical presentations also along with data. The presentation will attract the attention of the inspector on your data, and your attitude to develop such conclusive statistical evidences for establishing the control over the process. Try some examples on shop floor for hands-on experience. We will try to learn some more techniques in due course. Thanks for watching. For more videos, please do subscribe, like, and share. Thank you.